Acetylation of histones. Let's get to the marks, guys. Histones are proteins that DNA wraps around to form chromatin. These purple circles I've drawn are the histones. Now, these pink threads I'm drawing is the DNA, and this wraps around those purple circles to form something called chromatin. So, if we take DNA and histones, bind them together, we make chromatin. Now, you'll notice in this formation of chromatin, there's quite big spaces between the histones, and this allows the machinery of transcription, such as RNA polymerase or transcription factors, to access the gene. And here, in purple with the little arrow, is a transcription factor, or it could be RNA polymerase. And you can see it can get to the DNA and start reading that gene. Now, these green chemical groups are called acetyl groups, COCH3. And these groups, they actually change chromatin. They're the things that are allowing these big spaces and allowing it to be transcribed. Now, you don't actually need to know the mechanism by how these green acetyl groups are causing the histones to open up and allowing transcription. But it is to do with the fact that acetyl groups are negatively charged and the histone proteins are positively charged. So when the acetyl groups join, they neutralize the charge. Now, when histones have their positive charge, they will interact electrically with the DNA and make the chromatin condense. So what we're going to find now is that there is an enzyme that comes along and removes the acetyl groups. And when that happens, the histones regain their positive charge and attract to the DNA, and they condense the chromatin. Now, here's the enzyme. It's known as HDAC, or histone deacetylase. You can see it's removed an acetyl group here in its kind of mouth or its active site. The more acetyl groups that are removed by HDAC, the more highly condensed the chromatin becomes. And this means there aren't spaces for the transcription machinery like RNA polymerase or transcription factors like estrogen. They can't gain access to the gene, and the gene can't be transcribed, which means we're not going to make mRNA, which means we're not going to get translation. So in a way, the gene has been silenced, or we say the gene has been switched off. So acetylation of histones switches on a gene by allowing transcription factors in. Deacetylation of histones switches off a gene. So acetylation, like methylation, is an example of epigenetics, which is where transcription is regulated without changing the DNA base sequence, where we're changing access to the gene. We're allowing things in, or we're not allowing them in. Now, both of these are necessary and important processes. Neither one of these is a bad process. However, if it's not regulated properly, it can lead to the production of tumors and the development of cancer. Okay, guys, I hope that was helpful. If you've got any suggestions how I can make my videos better for A-level, please leave a comment. If you like it, if it was helpful, also leave a comment. Thanks, and yeah, subscribe if you can.